Alright, in this lesson you're going to do some calculating of z-scores and t-scores. Notice that we have a data set size 6. I've added up the column of data for you. So the sum of x is 41 divided by 1, 2, 3, 4, 5, 6, and found that the average score for that set of data was 6.83. I've gone ahead and calculated the standard deviation for you as well. So I squared each of the raw scores, then summed them up. So standard deviation is equal to the sum of x squared minus the sum of x quantity squared divided by n, all of that divided by n minus 1. Again, I didn't show you each of the individual steps, but we found that the standard deviation was 2.64. So what we're going to do now is go through and transform each of those scores into a z-score. So I'm not going to actually read each of these to you, but I am going to point out a couple of things. The first one is, we'll just talk about the raw score of 9. So 9 minus 6.83 divided by 2.64 gave us a z of 0.82. So the interpretation of that, and I would probably jot this down somewhere, that what that indicates is that the raw score of 9 is 0.82 standard deviations above the mean. The fact that it's a positive score, even though I don't have plus 82, it is a positive score. So again, the interpretation of that is that the raw score of 9 was 0.82 standard deviation units above the mean. So let's jump down and talk about the raw score of 6. 6 minus 6.83 divided by 2.64 gave us a z of minus 0.31. So what that means is that the raw score of 6 is 0.31 standard deviation units below the mean. So remember, z-scores represent the number of standard deviations. The original score falls either above or below relative to the mean. So which one of those raw scores was furthest away from the mean? And hopefully you determined that it was the raw score of 2, because the 2 was 1.83 units below the mean. Alright, let's move on to t-scores. So we'll again talk about those same t-scores, or same raw scores that we just used. So the t for raw score of 9 is equal to its z-score, 0.82 times 10. We'll do that multiplication first, and then add 50 to it. So the t for raw score of 9 is 58.2. And then let's look at the raw score of 6. Its z-score was minus 0.31. Multiply that times 10, and then add 50 to it. And what we find is that the t for raw score 6 is 46.9. And then lastly, the t-score for raw score of 2, minus 1.83 times 10 plus 50 gave a t-score for the raw score of 2 of 31.7. So later on you'll be doing some homework looking at or having you calculate actually t-scores and z-scores for a couple of sets of data. Now the second page of this handout we're going to talk about now, and the title of this page is Monotonic Transformation. Monotonic transformation. So what I've done for you is I have drawn the normal curve. I've put the mean in the middle. So the mean was 6.83. And then I identified the standard deviations at each of the points below the mean and each of the points above the mean. So the raw score that would have been at 3 standard deviations below the mean was a minus 1.09. The standard deviation, or excuse me, the raw score that would be 2 standard deviations above the mean was the 12.11. And then what I've also done for you is marked each corresponding z-score and t-score at their respective positions above the mean or below the mean. So a z of 1 is 1 standard deviation above the mean. A z of minus 3 is 3 standard deviations below the mean. A z of plus 3 is 3 standard deviations above the mean. For t-scores, 50 is in the middle. Notice, we'll jump back up to the z's, but notice that a z of 0 is in the position in the middle, so the mean of your z-scores will always be 0. The mean of the t-scores will always be 50. And so talking about the t-scores again, a t-score of 60 is 1 standard deviation above the mean. A t-score of 30 is 2 standard deviations below the mean. And again, I'm not going to read each one of these to you, but I wanted to orient you to what was going on. So I took the first 2 scores that we've been identifying and marked them in pretty close probably to their position on the curve. So here's our raw score of 6, here's our raw score of 9. And then what I did is I drew a vertical line down, and you can see it there is the dashed line. And so the raw score of 9, notice its calculated z-score was 0.82. So that's what we're saying is that's roughly right in here somewhere. And its t-score is 58.2. So again, within my ability to draw, that's that t-score. And then notice the same thing for 6. There's the raw score of 6. Its z-score was a minus 0.31, and then its t-score was 46.9. Again, within my ability to actually draw this, you can see that those positions are true whether we're talking about raw, z, or t. And I'm going to pause for a moment and let you identify the raw score of 2 on this diagram, and then I'll like I said, I'll pause for a moment, and then I'll allow you to draw it on there, and then I'll draw it before I move on to something else. All right, so a raw score of 2 is probably going to be right in here somewhere, and then we'll draw that line straight down. Again, within my ability to have to draw. Notice its z-score was minus 1.83, so it looks like we're pretty close there. And its corresponding t-score was 31.7. So that's a monotonic transformation. So here is a definition of monotonic transformation. What do you need to remember about that? Here it is. When a raw score is transformed to a standard score, and notice it doesn't matter if we're talking about a z-score or a t-score, so when a raw score is transformed to a standard score, its relative position within the distribution does not change. So when a raw score is transformed to a standard score, its relative position in the distribution does not change. A way I kind of think might help you think about it is if someone's given name is William, they're William. If we call him Bill or we call him Willie, we're just calling him by a different name, but he's still the same person. He's still William. So when you transform the 6 to a z-score or the 6 to a t-score, it's still in the same position within the distribution. We're just calling it by a different name, but we haven't changed where it is relative to the other scores. So that's monotonic transformation.